All right, folks, so in this set of notes, we're going to talk about density, which is something you should have heard before, at least in your middle school years, but if not, then we'll learn together here. First question is, what is density? I like to think about it as the degree of compactness of an object, or essentially how close the particles of an object are together. The more physics definition of it, or chemistry definition, is how much mass is stored in a certain amount of volume for a substance. Essentially, what this boils down to is not only how compact it is, but will it float or sink in a certain other substance? So a lot of times we think about things floating or sinking in water. If an object has a density that is greater than whatever liquid it's sitting in, then it's going to sink. But if that object's density is less than the liquid, it's going to float. One question before we get started is, what kind of units do we use? Again, it's the mass per unit volume. So we have to have a unit for mass. In this case, we're going to use grams most commonly. We could use kilograms or pounds or anything like that, but it's easier. We more commonly stick with grams. Volume is another part of this equation. One of the most common units for volume is liters or milliliters or gallons. In this case, we're going to use a milliliter, but we're not going to call it a milliliter. Turns out a milliliter is exactly the same as 1 cubic centimeter or 1 cc, which you may have heard in medical terminology. It's how they measure liquids in syringes and stuff. So milliliter usually implies that it's a liquid, but sometimes we have a solid that we want to find the volume of. So we talk about centimeter cubed because if it's a rectangular solid, we find the centimeters of each, the length, the width, and the thickness, and then we multiply it all together and you get centimeter cubed. Anyway, long story short, the unit that we're going to use most commonly is the gram per centimeter cubed. Okay. Just to give you kind of an idea, a little illustration of some common objects you might see, possibly test for in an upcoming experiment. We have this container of water here with a density of 1 gram per centimeter cubed. And any object that we have that we put in there that has a density that is less than that, it's going to float. Any object we put in there that has a density more than that is going to sink. So if we put a piece of wood in there with a density of 0.74, is it going to float or sink? Looks like it'll float. Aluminum with a density of 2.70 grams per centimeter cubed, is it going to float or sink? Well, it's bigger than 1, so I'm going to guess it's going to sink. Corn syrup with a density of 1.33, bigger than 1, so it's going to sink. A rubber band with a density of 1.52, bigger than 1, going to sink. Steel, much greater density than 1, with a density of 8.05. It's definitely going to sink. Then we have vegetable oil, which is just slightly less than 1 gram per centimeter cube. It's 0.91, and it's going to float just like the wood is. Again, this is just an illustration. It may not look exactly like this. But the whole idea behind density is whether it'll float or sink and the compactness of it in a certain volume. So the calculation again, well, again, it's mass per volume. So that kind of says the whole equation right there. You take whatever sample you have, you find the mass of that substance, of that sample, and then you divide that by the volume that you found for that sample, and that'll be the density of that substance. Essentially, it's just density equals mass over volume, or in short, D equals M over V. So as an example problem, we have a sample of an unknown substance with a mass of 40 grams, volume of 50 centimeter cubed, is it going to float in water with a density of 1 gram per centimeter cubed? The first step is to write our equation and our variables. We don't know density, we're looking for it, but it tells us mass is 40 grams and volume is 50 centimeter cubed, so we write that down there. And according to our equation, to find density, we just take mass divided by volume, so we do 40 grams divided by 50 centimeters cubed, and you get 0.8 grams per centimeter cubed. 0.8 is less than 1, so whatever that substance is, it's going to float in water. Another example problem, if it gives us density of aluminum as 2.7 grams per centimeter cubed, and the volume of a sample of aluminum is 10 centimeter cubed, what is that sample's mass? To do that, you have to take our original equation, D equals m over v, multiply by v on both sides to get m by itself. You get m equals v times d. When you write down density is 2.7, you write that down here. You don't know mass, volume is 10. All you have to do is take 10 times 2.7, or volume times density, and that gets us 27 grams. Notice that your units, centimeter cubed, are going to cancel out because you have it on top here and on bottom there, and you're left with grams. So our mass of this substance, is the sample of aluminum, is 27 grams. And the third example problem is how much volume would a sample of vegetable oil have if it has a mass of 91 grams. So we write down mass is 91. It tells us the density is 0.91. So we put 0.91 grams per centimeter cubed for density. We don't know the volume because we're looking for that, how much volume. And to do this, we got to start out the same way we did originally, or on the second problem, D equals mv, or m over v, and multiply by v on both sides to get m by itself. And then we got to divide by d on both sides to get v by itself. And what you end up with is v equals m over d. So you take the mass of 91 grams divided by the density of 0.91 grams per centimeter cubed. Notice the grams cancels out and the centimeter cubed will go up to the top of the fraction. You end up with a volume of 100 centimeters cubed, or 100 milliliters, if you will. So that should be pretty simple so far. And I hope that the video helped.